Everyone, today we're gonna learn 5.3 double integrals in polar coordinates. So we learn about the polar coordinate system in Calculus 2, section 7.3, polar, right? But then we did that earlier, section 2.7, cylindrical and spherical coordinate. So we extend the third dimension, that is a cylindrical coordinate, from the polar, right? So we are learning two-dimension polar coordinates here. Then polar coordinate system, we have a radius and angle involved, right? Okay, so let's take a look. I got the polar coordinate system from the Calculus 2 here. And look, Riemann sum. So double integration, Riemann sum. We try to find the volume or area, right? In the case, let's take a look. We have radius and A and B, and then theta, alpha, and beta, right? So we read alpha, right? In Greek letter, and this is the beta, I believe, like this, Greek, in Greek letter. Okay, now Riemann sum, we always have rectangles, right? So we take out the one small rectangle, and they shows us here, right? Okay, now same concept. How they find volume? Then height will be a function, and the times area, right? That's the volume. Then in that case, what's the area? We know that function is the same as a function, but area is a little bit slightly different here. So we are using area, r length times the thickness. Then r length, what's the formula of r length? Then theta times r times thickness, we are using delta r. Right? Okay, now we take out the small, tiny r length. So we want to express a small r length. Then how do we express? That is a delta changing tiny the theta times r. And then thickness, we are using same theta r. So basically we have extra r there in the area, right? Make sense? Okay, so this picture, I am explaining to you why we have extra r here. So Riemann sum, da-da-da, right? We knew. And then let's take a look. The function in polar will indicate in terms of r and theta, as I said earlier, right? Not the x and y, right? So if we have x, y, we have to convert. Then we learn from the calculus 2, what is the x? And then even earlier section, right? So r cosine theta, and then y equal to r sine theta, right? Okay, now area dA, we can use extra r and dr d theta. That's the area. Make sense? In polar coordinate. Okay, so if we are using in terms of r should be the limit from A to B. And then if we are using theta, then theta must be between from the R to, not R, alpha to beta, right? Okay, so let's do this example. This example has evaluate double integration dA, right? So we have dA, which means area, right? So let me write down. So that is r d theta, right? Okay. Okay, so I draw the nice picture. All right, so the radius 1, 2, 3, right? And theta between 0 to pi. So quadrant 1 and 2, right? And dA, which is r d theta, and then we don't have a function, so we just finding area here, right? Okay, so let's do it. So, what would you like to do first? dr, respect to r first? Okay, that's fine. So theta equal to 0 to theta equal to pi. Then r equal to 1 to r equal to 3, right? Then r d theta, right? So we want to integrate with respect to r first. Okay, so there is no theta, so we don't have to treat theta as constant, right? Okay, so let's do it. So theta equal to 0 to pi. Then we have r squared over 2. And evaluate from r equal to 1 to 3 d theta. All right, now theta equal to from 0 to pi, 1/2 3 squared minus 1 squared d theta, right? All right, then we have, can I say theta equal to pi, 1/2 9 minus 1, which is 8 d theta. So we have a 4, right? D theta. So integrate for the theta, which is 4 theta, right? So we want to evaluate theta equal to 0 to pi. So we will have 4 pi minus 0, which is 4 pi, right? So as I told you, we don't have any function here. So this is area, right? Not the volume. All right. Okay, so x, we know the x, we have to change it to the x equal to r cosine theta, right? And yeah, we change it to r d theta, right? Yeah. So let's do that. What do you want to do the first in terms of r first? Okay, that's fine. So theta from 0 to pi and r equal to from 1 to 2, then 3 times r cosine theta, and then r d theta, right? Okay, now let's simplify. So we have r equal to 1 to 2, so 3r squared cosine theta d theta. Okay, so let's integrate with respect to r first. Then we treat theta as constant. All right, so that will be theta equal to 0 to pi. And integrate with respect to r, so r cubed over r cubed over 3, right? And then cosine theta is the constant, so we keep the constant like a 3, right? Yeah. And d theta. Okay. Oh, I have to evaluate r equal to 1 to 2. Common mistake, right? And from 0 to pi. So r, which is 2, so 2q. And then cosine theta is the constant. 2 cube minus 1 cube, which is 1, d theta. All right. Then we have a minus 1, which is 7. So we get 7 cosine theta, d theta, right? And then what's the integrate of cosine theta? Sine theta, right? Good. So we have 7 sine theta. Then we evaluate from 0 to pi. Okay, 7 sine pi minus sine 0. What do you have? Yeah, it's 0. 7 times 0, which is 0, right? Okay, so in that case, we get 0 because cosine is even number, right? So I mean even function. Even function is like symmetric about the y-axis. Yeah. So we get the volume equal to 0. All right. Next to another one. Okay, so we have function that we want to evaluate. So basically, we need to find the volume. So normally we have given information about the region, right? So in here, we have R is unit circle. That means the radius equal to 1, right? So means R equal to 1. Then we can express the radius between 0 and 1. And then they said that on the xy plane, there is x and y plane. So from 0 to 2 pi, right? Means the theta is between 0 to 2 pi. Yeah, xy plane. Xy plane. Counterclockwise, yeah? CCW. Okay, so we can set up nicely like earlier, right? Like, or what's the reason where we have to find the volume? This reason, all right? So here, so we can make a nice format, r equal to r theta, right? Such that, we read such that, and then after that, detail, right? So this is a general, and this is a detail. Okay, so r is between 0 and 1, and theta must be between 0 and 2 pi, right? Okay, now we have a function. So I got a picture here, nice picture, paraboloid, right? Oops, excuse me. Okay, now let's take a look at this one. The function 1 minus x squared minus y squared, right? So let's make 1 minus x squared minus y squared. Okay. We had experience from Calculus 2 and the earlier section 2.7, the cylindrical, spherical, the coordinate, right? So this is 1 minus x squared plus y squared, right? Then we can express this one as r squared. Yeah, 1 minus r squared. Make sense? So r x squared plus y squared, we can express r squared because we are using polar coordinates. So we have to convert to everything as a r or theta, right? Okay, then dA, we can use r d theta, right? Okay, let's do it. All right, so let me rewrite one more time. So double integral region R, we have 1 minus x squared minus y squared dA. And then R, 1 minus x squared plus y squared. Then we will get 1 minus r and r d theta, right? r d theta. Okay. What do you want to integrate first? R first? Okay, that's fine. So easy one is better, right? If we try and then there's a complicated step, we should change that, right? So far so good, right? So let's distribute. All right, so we have to write down the limit. Theta theta is last, 0 to 2 pi, then the r equal to from 0 to 1, and r minus r squared, d theta, right? Okay, now, oh, missing r squared, yeah? Okay, so this is squared, so then we will have r squared and then r to the third power. Yeah. Okay, so we do integrate respect to r, what do you get? Theta equal to from 0 to 2 pi r to the third power over 3, r to the fourth power over 4. Evaluate from 0 to 1. Okay, so then we will have 1 over 3 minus 1 over 4 minus 0. Yeah. Theta. Wait a minute. Oh my gosh. I make a mistake again. Sorry about that. So let's see. We distribute. We get R here. Yeah. So sorry for confusion. All right. So let's change that. So R, correct? And then R squared over 2, yeah? And then 2, yes. Okay, so then 1/2 minus 1/4, so common denominator, 2 minus 1, which is 1/4. So theta equal to 0 to 2 pi, 1/4 d theta. Okay, now we need to integrate with respect to theta, so we get 1/4 theta. And evaluate from 0 to 2 pi. So we have 1/4. 2 pi minus 0, which is cancel out. So we have a pi over 2, right? This is the volume. For the paraboloid, and the region between r equal to 0 to 1 and theta equal to 2. 0 to 2 pi. All right? Okay, so let's do this one. Okay, so this is the last question for this section. We have a function x plus y dA. All right, so x, we're gonna change it later as a polar coordinate, which is r cosine theta, right? Y equal to r sine theta. And dA will be r d theta, right? Okay, so we have a given for the reason. Let's take a look. xy. What kind of xy is given? So x squared plus y squared is between 1 to 4. Okay, normally they give us as r, right? And we know that x squared plus y squared, we can express as r squared, like earlier, right? Okay, then the r square is between 1 to 4. Now we want to know about the limit. So r is between 1 and 2, right? Make sense? Okay, now they give us this condition. X is between, not between, x is less than or equal to 0. That means negative, yeah? So negative means between pi over 2 to 3 pi over 2, right? So quadrant 2, x is negative. Quadrant 3, x is negative, right? Okay, so let's do it. So let me rewrite reason r x plus y dA. There will be, what do you want to do first? R first? That's fine. So theta equal to from pi over 2 to 3 pi over 2. Okay, then x equal to r cosine theta plus y equal to r sine theta. dA will be r d theta. Okay, now we do distribute r. Oh, mistake. R equal to from 1 to 2, right? Okay, so theta equal to pi over 2, theta equal to 3 pi over 2, then r equal to, no, we distribute, so r equal to 1 to 2, so r squared cosine theta plus r squared sine theta, and the r d theta, right? Whew, I don't make a mistake, right? Okay, now we do integrate with respect to r. Then cosine theta, sine theta is the constant, right? So let me do that. Do first. Treat theta as constant. Okay, so that will be, can you see? Theta equal to pi over 2, theta equal to 3 pi over 2, r to the third power over 3, cosine theta, constant, keep the constant, r to the third power over 3, sine theta, constant. All right, so we do evaluate r equal to 1 to 2, d theta, right? Okay, so there will be theta equal to pi over 2 to 3 pi over 2. 2 to the third power over 3 cosine theta plus 2 to the third power over 3 sine theta minus 1/3 plus cosine theta plus 1/3 sine theta, right? And d theta. write down. A little bit nicer. Sine theta. D theta. All right, so what do you get? Combine your like term, right? So they are like term. So we have a minus 1, 7/3 cosine theta. And they are like term also 7/3 cosine theta, right? Theta equal to pi over 2. Theta equal to 3 pi over 2. 7/3 cosine theta plus 7/3 sine theta. Yeah. And d theta. Okay. So we want to integrate with respect to theta. So we have the first term sine theta, right? 7/3 sine theta plus second term negative cosine theta, right? Because think sine theta. Yeah, so that is negative cos 7/3 cosine theta. We want to evaluate pi over 2 to 3 pi over 2. Okay, so can you please think about that? What is the pi over 2 and 3 pi over 2? So that will be 7/3 sine 3 pi over 2 minus cosine 3 pi over 2 minus sine 3 pi over 2 minus cosine, sorry, pi over 2, right? Pi over 2. I don't know, I make a lot of mistakes. 56. Pi over 2, pi over 2. Yeah. Okay. So cosine 3 pi over 2 is 0. Cosine pi over 2 is 0. Sine 3 pi over 2 is negative 1. 7/3, negative 1. And minus sine pi over 2, it's a 1, right? It's negative 2. Negative 2, which is negative 14/3, right? Okay, so we have a negative for the volume, but this is not physical volume. Means that the below z-axis, right? It's below z-axis, xy plane, right? Okay. Any questions? Thank you for watching. I will see you in the next section. Thank you. Bye.